In 1820, okay, a German chemist, okay, named by the Friedrich Ackum, he identified many toxic metal colorings in food and drinks. So basically, adulteration of food. Just we have another one more person. Okay. So basically, class. Sorry for the this one. Okay. This chemist, okay, he identified many toxic metal colorings in foods and drinks. So class, basically what is adulterations? Okay, adulteration of food, basically they are cheats the consumers and possess the serious risk to health. So in past few decades, adulteration of food become a very serious problem. Perhaps the food adulteration is also a threat which silently kills the healthy society. So food is adulterated to increase the quantity and make more for profit. So here, class, food is basically, okay, any substance consumed to provide nutritional support for the body, usually of plant and animal origin. So here, contain basically food contains such as the nutrients, okay, of the food, okay, it contains such as the carbohydrates, proteins, lipids, okay, example rice, wet fruits, meat, okay, all these are, these the main thing, the nutrient are carbohydrates, proteins, and lipids. So class, now adulterants and food adulteration, okay, there are two different things. Adulterant is actually, an adulterant is any substance or substance found within other substances which is added to reduce the amount of expensive products, which is not allowed for legal reason. So adulterants is basically is just a substance, okay, they will just replace, okay, they replace with the expensive product, okay, they or reduce the amount of expensive product, they just put some low cost material such as adulterants, okay, which is harmful or it's legally not permissible, okay, it's not permitted, okay, by the by our rules and I mean, by our food act law. So food adulteration basically it refers to the intentional addition of some unwanted substance to food, or they remove some valuable substance from the food. That is food adulteration. That means purposely they are adding or removing something very valuable from the food. For example, adding of diethyl glycol, okay, in sweet wines, okay, this is the example. Okay, in the coffee also, they do add some roasted roots, okay, to the coffees. Okay, now, so there are three types of adulterants. For example, intentional adulterants class. Okay. For example, sand. Okay. Even sometimes in the rice, or sometimes in flour. Okay. We do came across with sand or very small kind of stone. All these are adulterants. Okay. So it's like intentional adulterants. Okay. And incidental adulterants is basically it's an incident due to the pesticide residue or droppings of the rodents, okay, laways in the foods, okay. And metallic adulterants is basically arsenic from pesticides, lead from water, effluent from the industries, okay. And tin from cans also can be, tin can be leached out from the cans, it can be metallic adulterants as well. So categories of food adulteration, okay, this is the food category of food adulteration class. So here, food adulteration is actually, we can categorize into replacement. That means complete or partial replacement of a food ingredient or valuable substance with less expensive substituents, or addition, we add something a small amount which is not allowed, or remove something very valuable, okay, without the purchasers or consumers knowledge. So that is, all these are food adulteration, categories of food adulteration. So class, here I would like to introduce a very basic analysis of adulterants in foodstuff. For example, milk sample. If let's say, class, The presence of water can be analyzed by putting a drop of milk on a polished slanting surface. The drop of pure milk flow slowly leaving a white mark behind it. So adulterated milk immediately without leaving a mark. So it won't leave any mark. So that is how they differentiate between a pure milk and adulterated milk. If let's say the milk contains some other milk do contain urea. So how to do this test? So 2 ml of the milk in the test tube, then half of the powder. This is the ahar powder. Okay, the contents are mixed thoroughly by shaking. So after 5 minutes, the litmus paper is dipped for 30 minutes and change in color from red to blue indicates the presence of urea in the milk. So starch. Okay, starch do contain in milk. For example, 2 ml is taken in a test tube and few drops of iodine solution. Okay, they do add iodine solution there. So formation of blue color indicates the presence of starch. So moving I mean and another one example of adulterants, which is formalin. Okay, in order to test the presence of formalin in milk, okay, basically 10 ml of milk is taken in a test tube and added 5 ml of concentrated sulfuric acid from the side of the test tube without shaking. So if let's say a violet blue ring appears at the intersection of two layers, that means it shows that formalin is present in the milk sample. Okay, for example, this is kind of butter. So 3 ml of milk is taken in a test tube and added 10 ml drops of HCl, hydrochloric acid, and also added one spatula of sugar. So the red colorization after 5 minutes indicates the presence of butter. So and milk product, this is pure milk class. Okay, this is based product. So all these are actually a very Indian famous food. Okay, all these are sweets based on the milk. Okay, they produce the sweets from milk. So for example, this kind of they will call these as the cottage cheese, ghee, or condensed milk or milk powder. So class, and they sometimes we I mean the color of this kind of food is very colorful. So um and it was some and it was at last, after the some simple experiment, they found that the presence of coal tar dyes. These are the coal tar dyes. Okay, so basically how they are doing the test: 5 ml of dilute sulfuric acid or hydrochloric acid, they added to 1 teaspoon of the melted sample. So pink color or the red color. Okay, pink color in the case of sulfuric acid and red color in the case of hydrochloric acid will indicate the presence of coal tar dyes. Okay, here ghee is a very pure kind of butter, but usually they do mix with margarine in the ghee. So how to how to check whether this ghee is pure or not? So just take 1 teaspoon of the melted sample and equally added to the concentrated sulfuric acid. So and we do add a pinch of sugar. So have to shake for 1 minute, then kept aside for 5 minutes. So the appearance of the red color will indicate the presence of margarine. If let's say the red color does not appear, that means our ghee is pure. So the rabi is something like a very sweet food. So even here same. Okay, they do indicates some bloating powder paper. Okay, presents and the sample, the a small portion of the sample with the sulfur hydrochloric acid. Okay, we can indicate some bloating paper there. So let's move on to the oil and fats. Okay, class. Oil and fats also, okay, been adulterated. Okay, for example, edible oil. So usually edible oil will be mixed with castor oil, linseed oil, and prohibited color. So how to measure all these oils? Okay, in the edible oils. Okay, usually class all the experiments. Okay, they use acidified hydrochloric acid and the few drops of ammonium molectate uh, is added and shaken well. So the appearance of white color, turbidity indicates the presence of castor oil. So that means class they mix the castor oil in edible oil. If let's say linseed oil means when we mix the sample with solution of bromine, yellow precipitate will indicates the presence of linseed oil, whereas the probated color, so when we mix the sample with 5 ml of concentrated hydrochloric acid, we have to shake gently. So kept aside for 5 minutes, the color will separate in the upper layer of the solution. So and we do I do include coconut oil and mustache oil. So for example, in the coconut oil we do can able to determine cyanide derivative or other oils. If let's say we want to determine cyanide derivative, so just take 3 ml of sample and 10 drops of alcoholic alcohol potash is added and heated. So a little amount of iron sulfate and iron chloride is added and shaken thoroughly. So once we shake the sample, so the 3 ml of hydrochloric acid added to the sample, so a blue color will indicates the presence of cyanide. So class, all these are examples of the adulterants in coconut oil. So where else? Mustard oil is actually in the mustard oil they do mix argemone oil, which is they detect by using this mustard oil with nitric acid. So and a red color will indicates the presence of argemone oil. So everywhere the adulteration is very famous. Okay, sugar. Okay, let's move on to sugar and honey is very famous class. Okay, so how to detect? Usually, chalked powder, which is calcium carbonate, okay, presents in sugar and urea as well. So how to know whether the sugar contain urea? We just dissolve the sugar, okay, in the water. So if the urea present, it will gives a smell of ammonia when dissolved in water. Whereas how to know the chalk powder, that means calcium carbonate present. So when we dissolve the sugar, the chalk will settle down at the bottom. So that means the presence of some impurities in the sugar lah, which is the calcium carbonate. Honey sample. Okay, class, a pure honey and a pure honey mixed with sugar water. So how to sugar solution, so um how to identify the honey is pure or not. So basically a cotton wick is dipped in the honey and burned over her flame. If let's say the honey is not pure and it's contain water, so it won't burn, and it will produce some cracking sound. If it's a pure honey, of course it will burn without any cracking sound. So that is how we determine the pureness or the presence of impurities in the honey sample. So this is the example of another one type of Indian very famous sweets class. Okay, all these are very famous in India actually. So all these Indian foods, okay, they use a lot of washing soda, chalk powder, which is calcium carbonate, and methylene yellow. Actually, this is the dye. Okay, so class, and all the method how to do the test is written here. Okay, and coffee powder here. Okay, coffee powder, they do have some starch, they do mix with starch. Okay, how to do this test? If let's say a small quantity of the coffee powder is taken into the test tube and added 3 ml of distilled water, well, the contents are heated until the solution become colored. So the added 33 ml of a solution of KMNO4 and muriatic acid, okay, will decolorize the mixture. So few drops of 1% equals of iodine solution will added. So the formation of blue color will indicate the presence of starch in the coffee. Okay, so this is the another one test, okay, to identify the impurities in coffee powder. Okay, another one class here, iron flakes, okay, in the tea leaves. So small quantity of a sample is spread over a paper, a magnet was drawn over it. So if the iron flakes are present, clings to the magnet, it will clings to the magnet. So we have to be very careful with what we are consuming. Okay, so another very famous adulterants are the wet rice, maize. Okay, so all these in class, and for example, the adulterants are like dust, stones, damaged grains. Okay, for example, rice, they do add boric acid, okay, as the preservative. Pluses, okay, this kind of the Indian pluses, a lot of Indian spicy foods, they use all these. Okay, so they use the lead chromate, okay, for the color and all this purpose. Okay, so the analysis is actually how to determine the in, let's say, the presence of stone and all that, we can observe visually. Okay, for example, the presence of boric acid. So small amount of sample of rice is taken and added some water, and we shaken well. So then we added few drops of concentrated hydrochloric acid. So a turmeric paper strip is deep. If it is turned red, it confirms that the presence of boric acid. Okay, for example, the presence of lead chromate in plasters. So 5 gram of plasters is shaken with 5 ml of water and added a few drops of hydrochloric acid. So formation of a pink color indicates the presence of lead chromate. So let's move on to the spices and condiments. So class black pepper. So usually the adulterants that we can find in the black pepper are papaya seeds. Okay, papaya seeds can be separated from the pepper as they are shrunken and oval in shape, so and greenish brown or in color, so we can separate that. Or sometimes they do coated with mineral oils, okay, and it will give some kerosene kind of smell. Okay, so you have to be very careful when purchase all these. So, and this is cloves, okay, usually we will use in food, and they do use adulterants are oil. Okay, identify in so the characteristic or smell of the genuine clove is less it's less compared with the volatile, the one that with the volatile oil. Okay, and in class all these kind of powders, okay, for example turmeric powder, okay, they do make the adulterants are colored sawdust. Okay, so we do can do some tests with concentrated turmeric powder with the concentrated hydrochloric acid. So we will observe pink color. So the pink color will indicates the presence of sawdust. So if the color is persists for a long time, it also indicates the presence of methyl yellow, methanil yellow. So which is a dye. So and this is hing. So this is also they do mix with the lead chromate. So again, class, the sample we have to dissolve in the hydrochloric acid, then hydrogen sulfate gas is passed over the solution. So black precipitate indicates the presence of lead chromate. So class, all these are actually examples of the adulterants. Okay, for example, this is the hing powder. So they do add soap, stone, or earthly material. Okay, so chili powder, okay, they do add sudan tree. Sudan tree is actually it's a dye. Okay, they do add that for the coloring purpose, and this is the analysis way to identify sudan tree in the chili powder. Okay, in the chili powder we can determine sudan tree and rhodamine B as well. Okay, class. Okay, this is the rhodamine B color. Okay, this is the example of the processed food. Okay, sweets, meats, syrups. Okay, all these. Okay, because in order to get the color, so they use, the adulterants such as the rhodamine B. This is a dye. So how to test the presence of dye in this kind of food? So a little sample of food is taken, then add 3 ml of CCl4 tetrachloro uh, okay, CCl4, and it's shaken thoroughly. So the mixture will become colorless, and addition of a few drops of hydrochloric acid, it will bring the color back if the rhodamine B is present. So this is how they do the test, class. Okay, just one moment, class. Someone is joining now. Okay. Okay, sorry for the interruption. So we have another one student just joined. So class, class, so far so good. Hello class, is everyone okay? Okay, thanks Norli. Okay, so vinegar. So class, vinegar sample, usually they mix the vinegar sample with mineral acids. So how to determine the presence of mineral acids in vinegar? So basically, few drops of vinegar is added to the methylene yellow indicator paper, and the color will change from yellow to pink. Okay, so this is the salt. So class, iodized salt, iodized salt and the common salt, so they do mix these two salt. So how to determine this salt is pure? So basically, a piece of potato is taken and added to the salt. After a minute, 2 drops of lime juice is added. In case of iodized salt, blue color will develop. In case of common salt, and there is no colorization. So that means, class, this is the test. So in case it's a iodized salt, blue color will develop, and in case of common salt, there will be no colorization. So that is how they determine the a very simple test to determine the presence of adulterants in iodized salt. So class, meat, all these kind of chicken meats and all those things. So they do, the presence of potassium nitrate, sodium nitrates, and sulfurous acid. So all these are another adulterants. Okay, and all the tests how to conduct the test is written clearly here. Okay, so basically you just have to know, the type of the adulterants presents in what type of food. Okay, the experiment, the analysis way, actually you can just go through that, class. Okay, nothing much. Okay, so class, harmful effects of food adulteration. So the adulteration are sure to bring about biochemical disorder by the any psychological disorders as well. So class, basically all these are the adulterants they use. Okay, and the side effects. Okay, for example, like mineral oil, liver damage. Okay, sawdust. Okay, liver disorder, toxic dyes. Actually, it is very carcinogenic, class, so you have to be very careful when you are consuming that. Like washing soda can cause diarrhea and vomiting and so on. So effect of adulterations on humans. Okay, adulterated food, frequent consumption of adulterated food can cause some allergic reaction, brain tumor, stomach cancer and liver. Okay, this is the, it's a normal liver, and this is the infected liver. So class, it's very scary picture anyway. So the what are the approaches that the control approaches that we can take? So basically, class, proper understanding of adulteration issue. So by knowing the difference between the natural and the adulterated food. Okay, accepting the natural ones to the extent possible. Okay, by developing the validated, simple and quick test procedures to scan the ingredients or additives. Okay, for the verification. and of course, stipulating the practical, the feasible rules, requirements, and regulations on the adulterants and updating them at the regular intervals. So, the regular update of information regarding the reported outbreaks of food safety issues, okay, pertaining to the adulteration. So, class, this is the food law of Food Act, which is Food Act 1983 by law of Malaysia. So let me open the file, Malaysian Food Act file. So class, this is the Malaysian Food Act file. Okay, you may download that from your Spectrum. So in this Food Act, okay, all the permitted food and what are the consequence if you take the food, so I mean eat adulterated food, and approved laboratories, and what are the procedure of taking the sample, so how to process the sample, so everything, all the rules and regulation is clearly mentioned in this Food Act. Okay, so this food X can be a good guidance for those who are doing food analysis. Okay, so class.